Another one of these same type of question issues. Can you see that these are the same questions? Part A says, a function little f has an antiderivative, capital F of x equals negative cosine x. Now they ask us to calculate the integral from a to b of little f of x dx for a equals 0 and b equal pi over 2. Is that the same question as part B? Evaluate the definite integral from 0 to pi over 2 of sine of x dx. Heck yes, that is the same question, because what is little f? What is little f? Little f is the guy for whom capital F is the antiderivative. Let's go ahead and solve this. Thus, the solution, since these are the same question, the solution to A is the same as the solution to B. So we can just work on one of them and we'll answer both of them. So we're going to concentrate, as we did last time, on the more complicated looking one, part A. Now, we know the fundamental theorem, part 2, says that if little f is continuous on the interval of x values from A to B, then we may conclude that the integral from A to B of little f of x dx is equal to capital F evaluated at B minus capital F evaluated at A, where capital F is defined to be the antiderivative of little f. So the integral of little f is equal to the antiderivative evaluated at the upper limit minus the evaluation at the lower limit. Okay, so what are we given in part A? We're given that the antiderivative capital F is negative cosine x, A is 0, and B is pi over 2. Okay, so what do we know? Well, here's something we forgot to state last time. It's important to state this. We know that cosine x is continuous for all real numbers x. So that tells us that negative cosine x would also be continuous. A negative sign is not going to change continuity. And we are therefore able to use the fundamental theorem. So we're just making sure that it's cool to use it. And yes, it is. Okay, so let's find little f. That's important. That's like step 1 for evaluating the function, the integral in part B. Find little f. Well, capital F equals prime equals little f. So we're looking for little f equals a derivative with respect to x of capital F of x. So in other words, it's a derivative with respect to x of negative cosine x. Okay, the derivative of cosine's negative sign, and then we have a double negative, makes it positive. So f is equal to sine of x. Okay, great. Then that means that the fundamental theorem, part 2, implies that the integral, now we're answering part B essentially, the integral from 0 to pi over 2 of sine of x dx is just the evaluation of the antiderivative at the upper limit minus the evaluation at the lower limit. So it's capital F of pi over 2 minus capital F of 0. Well, what was capital F? We saw that it was given to be negative cosine x, so it's negative cosine pi over 2 minus negative cosine 0. Well, what is the cosine of pi over 2? It's just 0, and the cosine of 0 is negative 1, so we've got 0 minus a negative 1, so the answer is positive 1. So you see what's happening here is once we recognize that the questions are the same, we can actually jump right in there and answer part B, or the version of B, the version B of the question. We can find this definite integral by step 1, finding the antiderivative, capital F, the antiderivative of little f, which is sine x in this problem, and then evaluating it first at the upper limit and then subtract the evaluation of the antiderivative, capital F, at the lower limit, and that number will be our answer. It actually looks very simple like that.